Hello friends, welcome back. In the previous tutorial we have seen or we have learned how to find out whether two vectors are at right angle or acute angle or obtuse angle, which is really useful, and we have seen the dot product formula. In this tutorial we are going to see an example for that, and it is simple to understand. Now if you see here, let us take, this is the x-axis and this one is y-axis, and let us take you have a car game object placed exactly at x equal to 0, y equal to 0, z equal to 0. That means you have kept a game object at the origin. Now here we have global coordinate system. There we have a right vector which is 1 0 0, then up vector is 0 1 0, the forward vector is 0 0 1. And as I told, every game object that you bring in is going to have its own local coordinate system. It is also going to have a right vector, forward vector and up vector. Initially when you bring a game object, if you do not make any modification to the game object, it is going to have the right vector exactly same as the global coordinate system's right vector. Forward vector is same, you can see, up vector is same, you can see. Now let us take this car is moving in this direction. It is moving right. If it is moving in this direction, you can say that the car is moving straight. You can say the car is moving straight. How do you say that? How do you say that the car is moving straight? Understanding? Now here what we do, we are going to identify the angle between the right vector and the up vector. What we do means, we take the global's up vector, we take this vector, the global's up vector, and we take the car's right vector, and we find out the dot product. If I get the dot product exactly 90 degree, then I can say that the car is moving this side, and of course the angle between the car's right vector and the up vector will be 90 degree, right? So let us try and understand step by step. We write code and get some information. Now first of all, what I do, I create a right and up vector in the vector 2D structure. Then we use that one. Let us minimize this, let us minimize this and come to the Unity. And here we have the assembly browser. There we have a vector 2, and you can see what the right vector is. The right vector is a public static vector 2, right? It's a property, a static property. It's a getter. It returns the new vector with the value 1, 0. So I can copy this or I can paste it, type it. There is no problem in that. We are just understanding. So this is the right vector. Let us create the up vector also. So we create a public static vector 2D. It should be vector 2D because we are creating our own structure, vector 2D, which is going to be up, and it's a getter. And what it does, it returns a new vector 2D, and the up vector, we know that this is going to be 0.0f or 0f, 1.0f or 1f, that is same. So up vector x will be 0, y will be 1, and if you want you can see that also here 0 1. So we have the up vector and the right vector which indicate the global up and right vectors. Now what we do, we proceed further. Let us delete all this code. Let me delete this complete code and let me save this. Now here we have what I do, I create one simple class. Let us create a public class which is going to be named as a car, which is going to be a game object. I can say a car, or I can say game object, something like that. I can say game object only, there is no problem in that. Now this game object is going to have the right vector. So I take a vector 2D which is going to be public, public vector 2D, RIGHT, right vector. Now this is going to be a right vector, guys, and here I create the public constructor, public game object, that is our public constructor, and let me initialize the right vector. Right vector is equal to new vector 2D, and its value I am going to set to the right vector initially is going to be 1.0f x, and y will be 0.0f, 0.0f or 0f, right? That is the right vector. You can see the right vector has the value 1 and 0. The same thing we are writing here, right vector is 1 and 0. Now what I do, I create a game object here, game object car is equal to new game object. If you see, and if you want, you can create another vectors also. Let us take, I create another vector like vector 2D. This is going to be the position vector, POSITION, position vector, vector 2D, which is also public, POSITION, the position vector, and initially the position is going to be equal to new vector 2D of 0.0f, 0.0f. So we are going to place our car exactly at 0, 0, 0. Now let us save and check out. We are going to say debug.log, debug.log. I just want to display the car position, car POSITION, position x equal to 0, x equal to double quotation plus car dot position, car dot position dot x, that gives me the x position of the car, plus double quotation y equal to double quotation plus car dot position dot y. So I get the position. Then I also want to display the right vector, car right vector, car's right vector, that is the local right vector. So car dot right vector dot x, car dot right vector dot y. Very simple. Now what I have to get, car dot position dot x should be 0 over here, then car dot position dot y should be 0 over here, then car dot right vectors x should be 1, car dot right vectors y should be 0. That is what we have set. Let us save, come back to Unity. We are creating a game object. Inconsistent accessibility field type vector 2D is less accessible than the field game object right. Where is that? Let us check it out. So here we have the problem. So both of them are public first of all, and here the structure is not public. Let me make it public so that I can access it anywhere else. Save it, come back to Unity, and the error has gone. You can see that. Now if I run the code, you can see that car position x is 0, y is 0. That is what we have here. Car position x is 0, y is 0. It is exactly at the origin, guys. You can say that car is at 0, 0. And of course the right vector, as we know that it is going to have x1, y will be 0. If you want, you can create the up vector, forward vector also in the car game object if you want yourself. Anyhow, step by step we add those things and we understand very clearly. We get, at present this much is enough. We got the right vector, so we have position as well as the right vector. Now what we want now? We want to check what is the angle between car's right vector and the global vector 2D's right vector. So let us check it out. What we do, we are going to create a float. R value, that is going to be a return value, is equal to, we are going to use the vector 2D dot product. So what dot product takes? It takes two vectors. So let us give car's right vector to it, comma global vector 2D's up vector dot up vector. So here we have the right vector and the up vector. You can give any one. You can give first up vector, then you can give the right vector. There is no problem in that. Let me say control X and comma, control V, comma. So this is going to be A vector, this is going to be the B vector. It will give us back R value, which is going to be 0 in our case, because we know that this car.write is 1 0 and up vector is 0 1, so definitely we are going to get 0 at the end. Debug.log, you can see the R value I am going to display here, and if you save, definitely you should see here 0, that is going to be the last output. And this code is not much difficult, very easy code, you can understand. If I run the code, you can see that the last output that we got is 0. So what I can do now, I can say here, if R value is equivalent to 0, if I get 0f, then I can say debug.log, I can say car is moving straight, STRAIGHT, straight. So if I save, or horizontally also I can say, if I save and run the code, I should get here the last output as car is moving straight. Let us run and check. You can see that car is moving straight. Now we have identified, this is how you are going to check whether car is moving straight. You can do some other operations also. I hope you guys have understood. It's very simple. If you have any doubts, please put the breakpoint and check out how it is working, because it's not much difficult. Now let us proceed and get the next example I have here. Let us take if car is going like this, if car is moving up, if it is going up like this anti-diagonally. So you can see actually now your car is little bit rotated, right? You have rotated around the forward vector or z vector. You have rotated your car in this direction, guys. You have rotated, maybe you have rotated by 45 degree. Now when you rotate your game object, then you should see here the local right up and forward vectors have got changed, whereas global vector is still same. The global coordinate systems, all vectors are same. The right is still 1 0, forward is 0 1, up is 0 1 0. That is same, whereas local coordinate system of the car has got changed. So this time you have the right vector of the car is now 1 1. You can see that if I draw the xy plane, you can think this one is 1 unit and this one is 1 unit. You can say this this point is 1 1. Understanding? Now what we are going to do, we are going to take the up vector, we are going to take the right vector of the car, and if I put it something like this, this is the global vector's up vector and the car's right vector, and we are going to find out the angle. We are going to check whether we are going to tell whether car is moving up or not by performing the dot product between these two vectors. This is the global up vector, this is car's right vector. Understanding? So it's very simple. Let us check it out. We have to get the value here greater than 0. If I get the dot product greater than 0, then I can say the car is moving up, or we can say the angle between the right vector and the up vector is, we say, acute angle. What I do here, I come back. This time I am going to change the car's right vectors x and y position. So I say car dot right vectors x is equal to 1.0f, then car dot right vectors y is equal to 1.0f. So here I have changed the car's x and y, right vectors x and y, so to indicate that car has rotated, and the position will be same, but the right vector is going to get changed. So here I just paste it, I save here, car's right vector is going to change to here, I should see 1 1, right? The global up vector will be same. So this time what we are going to perform, again I am going to find out vector 2d dot product between the vector 2d up, this will be same 0 1, but car dot right is now we have changed to 1.0f 1.0f. So I'm not going to get the 0 this time. I'm going to check here else if the return value is greater than 0, that means I am getting the positive value, then I am going to say debug.log car is moving up, or I can say the angle between the car's right vector and the up vector is acute. So let us check it out. If I get this, and also you can see if r value is greater than 0, it should be acute. You can see here, if it is greater than 0, the return value is greater than 0, then we should say acute. Let us check it out then. Let's come back. I should get here car is moving up. I should not get car is moving straight. If I run the code, you can see here car dot position x is 0 0, right is 1 and 0, car position is x 0 y 0, it's same. Car dot right is now x equal to 1, y is equal to 1, and you can see car is moving up. Can you see that? So this is how you can use, and you can write the code in this place. What should happen if car is moving up? What should happen if car is going straight? That code you can write in these places. Now let us take, I rotate the car. Let's take the next example. I take the third over here. So we have seen this now greater than 0. Let us take another one. Now this time you can see car is moving down. If car is moving down, you can see its local angle, local coordinate system has got changed. The right vector has the value -1, right? If I draw x-axis and y-axis, here x and y, come on, let me take a little bit. So if I have x and y, you can see the right vector is, let us take here 1 unit, here 1 unit. So this one is here you should have x1 and y is -1, right? X should be 1, y is -1. This is not 1. So let me remove this one. X should be 1, y should be -1 and 0. What I do this time, I am going to change again the car. Car dot right dot x is going to be 1.0f only, no change. Then car dot right dot y is equal to -1.0f. This time the car has got rotated. I am not going to display these things because are not necessary for us now, right? So I think this much is enough. So we have a car at 0 0, then car's right is now 1 -1, up will be same as it is 1 and 0. I can say here else, else if r value is less than 0. If I get less than 0, then I should say here debug.log car is moving down. So let's save it, and also we display r value here so that we see that we are getting the negative value. So r value. Now try to understand, this is not much difficult. So let us save. Let's come back, clear this code, stop this and run the code. You can see that it has returned -1 and car is moving down. How useful it is, guys. So this is really useful code, and you people can understand. Now what I do, I just put a breakpoint over here, attach the debugger so that you people can understand. Let me explain it step by step how it is working. You people can understand. So if I run the code, you can see here we have the game object car is equal to new game object. Still car is null and r value is 0. If I execute this, the car object is going to get created. So first I say step into. If I say step into, it goes to the game object, right? It goes over here, it sets the right vector and the position. Let us see that. I go up, we are here, we are in the game object now, constructor, and this is pointing to our newly created game object, which is having the position property set everything 0 0 0. Then the right vector, if you see, it is also having 0 0 0 magnitude, and normalizer is of course should be not a number at present because we have not made it smaller. That's okay. Now here it creates again a new vector 2D with the value 1.1 and 0, and it returns back to us, and that we assign to right vector. Once it will get created, the right vector is going to have the x1, y0, and the magnitude will be 1. You can see that it goes to the vector 2D constructor. You can see that here it said this dot x and y. This dot x is 1 and y will be definitely 0, right? And it comes back to us, and here this dot right vector, if you see, x is 1, y is 0, magnitude is 1, and its normalized vector's magnitude is 1. You can see that x is 1, y is 0. That is the normalized vector. Then the position vector is going to get created with 0, 0. I just step over because I need not to explain this. Then we are going to have the position vector also created with x0, y0. You can see that. Then it comes back to us. Car is created. You can see it has the right vector x1, y0, magnitude is 1. Now we are going to change the right vector to x is equal to 1, y is equal to -1. We are going to set here. So let us step over and step over. If you see car's right vectors, x is 1, y is -1, then we are going to calculate the dot product. So when we calculate the dot product, you can see the up vector is x0, y1, that is correct. Then the right vector we have x1, y is -1, right? Then it goes to the dot product method and gives us back the result, that is -1. So we got the result -1. Our value is -1. So what happens here? We step over. Now our value is -1. So -1 is equal to 0? No. It goes to the next step. Whether our value is greater than 0? No. It is -1. So it comes over here. It will check whether our value is less than 0. Yes, -1 is less than 0. So it goes and says car is moving down. You can see that it has went inside and it gives us the result car is moving down. So this is how the code works, guys. I hope you guys have understood this. It's very simple. Step by step you get a lot of idea, you get clear idea how do you write codes, how do you understand each and every concept graphically. So we have understood the dot product, how do you calculate the dot product, and we have understood when we use the dot product, how it is useful in a real-time example by taking this car example we have taken, and you can use in many places. So please try with some other examples. I think for this tutorial this much is enough, guys. In the next tutorial we are going to see some other example so that you get a clear idea where and all you can use the dot product. So for this tutorial this much is enough. Thank you, guys. Thank you very much. See you in the next tutorial. Keep learning, keep coding. Thank you, guys. Thank you very much. See you in the next tutorial.